in IBM, and he'll be taking a lecture on role of IoT in smart cities. So, Dr. Madhukar, please, you can take over the session.
Sure, thank you. Good afternoon, and I'm really hopeful that you are having a great lineup of sessions so far. Uh, Today I have a brief to present around something on how AI and IoT are being utilized in the smarter city space. So I'll quickly share my deck with you, and maybe we can go from there together. So is this presentation visible to you?
Yes.
Okay, great. Um, okay, so let me
On the bottom screen, you'll be saying hide. Stop sharing के साथ में hide होगा. Just click on that hide. That's it. Thank you, sir.
Okay. So I'll be delving during the course of next whatever 45, 60 minutes into various aspects about what IBM brings to the table in terms of expertise and use cases that we have been working on. And I'll also trying to bring in a flavor of like what's the typical integration of IoT and AI that we see in this space. And we'll also touch upon the cognitive pieces, in terms of integration, self-learning ability of various platforms that we have been working. Now, we have been working in this space for almost like 12 plus years, and we have worked with almost 30,000 plus cities, across different projects, be it transportation, water, public safety, or, smarter grids for that matter. And in terms of the capabilities that we have been trying and integrating is like city operations is one, analytics is another, mobility is another vertical, another horizontal in which we have been working on these cities. And IBM has been an industry leader for that matter, according to the report from Forrester Research, Frost and Sullivan, and Emergent Research. At IBM, we have a very strong focus on intellectual property development and patents. And I'm not sure if you've been following it, but then for last almost like so many years, we have been consistently at top in terms of patents and all. This year, in 2018, we had almost like 9,000 plus patents across different IBM teams. Now, this is a brief snapshot around which all teams have we worked with. We have basically worked in two markets. One is the major markets, and the other is the growth markets that we see. Major markets comprise of almost 51%, and you can see a few cities which are mentioned there, right from Madrid to Chicago to Milan to Stockholm, London. You name the best of the cities, and you'll find one there, right? Similarly, from the growth market perspective, you can actually see a country like a place like Nairobi, or you can see like Taiwan, or even for that matter, New Delhi or Bangalore or Singapore, where there have been some projects going on. Now, these projects have been going on in different segments. One is public safety, two is transportation, smart transportation, three is water, energy, healthcare, education, telecommunication, and social services, right? So let's try and understand where is this overall idea of smart cities comes from, right? With so much movement of population towards urban cities, of course, the resources are anyways limited, right? So what happens is, these resources come under huge stress, and the performance of the city as such starts underperforming. So that's where smarter concept came into play, where we said we'll try to do the management of all these resources, be it energy, be it healthcare, be it logistics, be it transport, be it waste, using the technology, right? Using some mechanism of, since we are so strong and we are so advanced in terms of information communication technology. So, the integration of both these pieces together is what is smart city. Few basic components in any smart cities is one is the technology piece, which talks about the various hardware components, various computing infrastructure, various software that basically integrate these hardware components. Second is various people who are working to make this integration, and third is the government policy, which are there, right? So from a IBM perspective, the overall smarter city solution portfolio primarily comprises of these application services. So there is something called as an intelligent operations center. I'll take you all through the deeper aspect of all these things later on. So there is something called as an intelligent operations center, which basically provides for like a command and control center for all the various service integrations. There is something around emergency management, which is again a component, which is again an application on the overall strategic services offered. There is a building management service. There is something called as a campus management. There is a transport management thing. There is a utility network management thing, right? There is something called as a smarter care and a health management thing as far as application services are concerned. And all of these actually come as are being provided as end-to-end smarter cities capabilities, and the various domains they all come and integrate as one is municipal operations. So for each city there will be a certain municipal limits under which the city operates. Two is the water, smart water management, safety, public safety, transportation, and of course logistics domains in which these solutions are offered. So, well, typical smart cities operations are a smart grid or a water management. So we just talked about that. Let's dig into one of these to understand more about these applications. Okay. So what I'm taking is a smartest electricity system as a use case for a discussion for next few slides. We recently also developed a course with NITTTR Chandigarh, which is offered on as a MOOC course on Swayam, which is around smarter cities, real time power management in the smarter cities area. So that the domain is again real-time power systems, but then it is in terms of a smarter cities, smarter grids for that matter, right? So I'm just taking up that particular use case for the conversation in this session for us. So as we see today, right? So there is a transmission and a distribution control center, which basically connects the last mile, that is typically the residential residences to various industries, various commercial customers, and this last mile is between the substation and the particular consumer, right? What we basically are talking about in future, where we're talking about a smarter city system, and this is not future. This is now you would know better. This is now actually a present system in a lot of these places where we have all these non-conventional energy resources coming and getting integrated on the grid itself. And you have the transmission control center and the distribution control center, which is being managed more through a information and communication mechanism, right? And you got these multiple energy service providers coming and collaborating on a grid, and the grid is basically used to energize a lot of electric vehicles, a lot of other subsystems. It also basically takes into account the various energy generation being done by the non-conventional sources, renewable energy, typically like a solar energy or a wind energy. So in that case, where the consumer itself becomes the producer and feeds the grid back with the excess electricity that they produce over a period of time, right? So that's what is the future of, or the the upcoming smarter electricity system that basically we talk about, right? And what happens is, to enable all this, there are a lot of these sensors which create huge amount of data, right? So there can be smart solar inverters. There are a lot of these wind energy data sensors, and of course, since we tap into weather data as well, so what we do is we bring all of these systems together. I'll later on go into the things like how do we do that, and we integrate all this together in terms of understanding few things, right? So one is our demand side management programs using this data that we get. Two is we create an advanced metering infrastructure, right? Three is we basically have a mechanism for event classification and detection, and then there is a power system state estimation as well, and there is a enhanced system security and protection mechanism which is being put. So all of these use cases typically leverage both the IoT and the AI side of IoT, right? So it's like a sensor, pushing the data back onto the cloud using some gateway. And once you have the data, you are doing some sort of analytics in terms of deriving the value, right? So this is a typical three-layer, three-view energy model, analytical model, which talks about one, the synergy model at the top layer. There is a services, a stack model, if you see there at the right-hand side. And then there is a component model at the bottom of it. So there are various components which basically integrate. If we see the analytics component model, you'll see various subcomponents there, right? There is an event generator, there is a pricing engine for energy, there is a dashboard, there is a statistical analysis tool there, there's a data mining tool there, there are power calculators, there are data collection engines as well. So the point is all these components, all these engines are integrated together to form a analytics component there, right? Once you have that energy component there, you basically, give me a second, please. Once you have all these components churning out these data and integrating the analysis for you, it basically provides for a synergy model, an analytics synergy model, where you get various telemetry or event messaging coming up. You have got the users data coming up from various meters, consumer meters, commercial meters, whatsoever, and they actually get fed into the system, right? So if you see on the left hand side, the analytics synergy model, which basically comprises of the various sources at the bottom, which and then they are classified into data classes, which in turns is fed into the analytics service, and then you have various dashboards which figure out what sort of services is requiring what sort of attention. So many of these services are even automated for that matter, right? We will see that also in due course of time. So these are a few analytics which can be derived in terms of what we just discussed, right? You can have a improved billing accuracy, so that in case you can predict for last 1 month, for last 30 days, this had been an energy consumption model based upon the weather, whether it's a cold weather in a particular geography or not. You can give a predicted prediction to the customer based upon this consumption patterns over last few months or few weeks, that what he should expect as a bill for the next month, right? Similarly, there is something around the data analytics for detecting the health of a meter, whether it's being working fine or not. Similarly, there are so many, like there is a mechanism for fault toleration, for fault isolation and restoration as well. As I said, a lot of these is automated. So, for example, if there is a load which has gone beyond a certain limit, and for some reason the particular appliance is stripped off, you can remotely try to restore that particular equipment based upon IoT device controlation. Similarly, if you talk about the time of usage rate, so you can also define a customer, so he can prioritize when does he wants to actually use a particular appliance. Say there is a peak hour rate, then there is a non-peak hour rate. So if a customer has a visibility that in non-peak hour the rate to be followed for a particular energy is this much, then he may try to prioritize his jobs, so that he can optimize his overall expenses. Similarly, the energy users rates can also be both optimized as well as predicted. And the consumption patterns can also tell the grid or the producers how much electricity at some point in time can be needed in due course of time. Similarly, in case there is a environmental hazard which has happened, like there is a storm, upcoming storm, or there is some other issues. So based upon those weather predictions, the service provider can isolate a particular system, right? He can cut off, or maybe he can provide for alternate arrangements uh, based upon the prediction of the weather which is coming into the system. That information is fueling the various decision making. So decision making is also one of the key components in terms of deriving the analytics based upon the information which is made available. So IBM has something called as IBM Watson IoT, uh, and this particular platform provides for integration of a lot of things there, right? So I'll quickly um, show you first this piece, and then I'll go back to this. Now, what happens is in this platform is you'll have these multiple devices or gateways wherein you have these sensors coming in and pushing the data, right? And so what happens is these all connect to the IBM Watson IoT platform, which is a service available on IBM Cloud through one of these protocols. So, for example, MQTT, right? So what happens is the device data is basically secured end to end, and it is sent using a lightweight messaging protocol called MQTT. Now, what this IBM Watson IoT platform provides for it, it has a range of offerings, good number of offerings, and these offerings can be leveraged using either a REST or a real-time APIs. So there is an API call based upon which the data can be ingested, and it can help in giving you, at the end of the day, you basically get some analytics out of this data. Now this analytics can be like a dashboard, or it can even fuel some other service, it can trigger some other service as well, right? Okay, so let me quickly take you through this piece now. So if you see at the bottom there are various devices which basically connect through the different protocols at the device level there. And this data is basically used for analyzing and optimizing. And henceforth, at the platform layer, you have the design, or you have industry specific solutions which are using this data and these this particular platform. At the solution layer at the top, if you see there are various industry partners with which IBM works. Say, for example, we're working with Toyota in terms of a connected car. We're working with so many healthcare companies. We're working with so many, there is a global bank called ISS, which we're working with towards smarter building management, right? And so you can see at the top there are various solution layers where you have integration of all these analytics, which is basically derived using the. So as of now, what we see is a 53% of operational efficiency integrating this together. And from a, as I was talking earlier, from a decision maker's perspective, 85%, really increase is a huge increase in terms of a improved customer experience driven by, IoT solutions here. A couple of more capabilities of the IBM Watson IoT platform. One is it can be used to connect. So it's primarily a service wherein you can plug in the various devices, you can configure a gateway. Two, you can do all that information management. This information can be either a structured data or unstructured data, which can either be, coming streaming in from various devices, or maybe data at rest, like a typical conventional databases. They can be all integrated over the IoT platform. This is another good layer there, which provides for the analytics piece, which gives a great insight, from the information which is being flowing into the system. It can be both a real time, it can be a predictive, and it can be a cognitive analytics as well, right? So, for example, there is a real time streaming service available on IBM Cloud. I'll give you a small example. So, there is a service which talks about a driver's behavior, right? A driver's behavior service. So, on each of these cards that you have a OBD port, you can connect the data, you can connect the OBD port adapter there. And the data starts streaming at the backend device using a Bluetooth connection, right? It can be a mobile phone as well. If you stream this data back to the service that I'm talking about, this can actually give you real-time behavior pattern of a particular person who is at the wheels of the vehicle, right? So based upon how he's braking the car, based upon how he's actually cutting the corners, based upon the various engine statistics that are made available on the OBD port, you can predict the driver's behavior, right? So that is something like a predictive analysis. Similarly, and this incorporates the real-time data, because it's like data in motion which is flowing in from the OBD device, right? Then it also provides for a risk management capability, so that you can leverage the information at the right time, and you can use the right software whenever you need this. Right? From India perspective, we have a very strong story to showcase from IBM capabilities and experiences in India. So right from our integrated command and operation center that we had established at the Rashtrapati Bhavan in Delhi sometime back, which has a great synchronization of various sensors which operate and which control various aspects of the Rashtrapati Bhavan, right from water to electricity, to various other appliances. There is something which we work with the Mumbai Municipal Corporation towards surveillance. It's again an integrated command control center. We also worked with Sheltrex for a smart township, which is like a work in progress. And Pan India, we've been working with a lot of these banks for brand security. If you see there's a mention of Axis Bank there. Besides, within the organization, we also use it. There is a project which was underway with Ludhiana, which is close by for you, which was around a smart city proposal. And there's a lot of work happening at Surat, right, which is again both establishing of command and operation center, and it integrates various subcomponents to it, including waste management, including water management plan, including traffic management thing, right? So this is something which is like a complete package there. Similarly, there is this Lodha city, if you would know, it's a very high premium township, which basically again has there is a lot of work which has happened in terms of township strategy and integration of the command and control center with the various components there, right, which are available. So this is just basically a drill down into the various service. Before I go into this, I'll just like to take a pause here, and I'd like to understand if there is any question, from the room. Any question, folks? Anything around whatever we talked so far?
If you have any question, you can come and ask the question.
Okay. So let me go further in case you don't have any question right now. Maybe you can park it for later on, and we can definitely take it up at that point also, right? So I'll continue with this piece for now, and yeah. So what I was talking about was I was talking about some applications of both AI and IoT in various work that we have done, right? So there is something called as a Municipal Intelligent Operations Center, right, which basically integrates both data analysis and coordination across various city systems, right? Now, what are the various city systems? It can be a waste management thing, it can be a water management thing, it can be electricity or a traffic management thing as well. So we have done this, at least at 3 places in India: Surat, I told you, Lodha city, and the Rashtrapati Bhavan, right? Um, Now, what we have done is we have actually tried to integrate all the three things using centralized monitoring of various key functions, and what also has been we have been able to do is we have been able to provide analytics to the decision makers in terms of predicting and preventing the issues that can actually affect various issues, like particularly related to health, particularly related to traffic or transportation or certain emergencies. Now, what we have seen is it has really led to a lot of optimization of cost and minimization of revenue leakages. I'll give you one small example. So we are recently working with one of these premier institutions for doing a hackathon, and one of the use cases in the hackathon is this, what I'm going to explain to you. So in every city, there's a lot of hoardings that you see, right? There are a lot of public places where there are a lot of hoardings are being put up. Now, these hoardings are sometimes uh, paid for. There is a revenue that you pay to the municipal corporation for putting up the hoarding. But if you say out of 100 hoardings, you may find 30 to 40 such hoardings which are just put up like there, which are illegal, if you say from a legality point of view, and which they would have not paid the needed revenue to the concerned municipal organizations, which is basically a revenue leakage for these organizations. What the kids are going to do as a part of this hackathon are they're going to make a crowdsourced solution in which anybody who's a passerby, they can actually click a image of the hoarding which you see right in front of you. This image of the hoarding is fed back to the system, which is already trained in a certain manner. Now, what has happened is whatever approvals municipality has given for a hoarding for a calendar year in a particular location, the classifier is trained to recognize all of those use cases, all of those, once you click this picture there and you upload it on the system matches this image with the classifier which is already trained with the right or the legal set of images or legal set of advertisements which are available with the municipalities. If it matches, good. If it does not matches, it basically triggers a notification to the various decision makers in the municipal organization that this is a particular hoarding, this is the latitude, longitude of the particular hoarding which is being put up in a certain city location, and they can actually not only this much, it also does a lot of text analytics to understand who are the people who are behind to put this advertisement. So what they can do is they can actually go back and they can check with these people if they've obtained necessary permission. If not, they can realize the revenue from that particular hoarding. Now, this basically is a beautiful integration of IoT and AI capabilities, right? So you have a natural language classifier there. You have a machine learning engine at the backend, which is trained to identify images. Visual analytics is being doing the play there, and which all the images are the right ones, which are the images which you should be rejecting, which are not the ones which have been approved. And you have these mobile phones, which basically are most ineffective mechanism, more inexpensive way to do these things, right? You simply click a picture and you upload it there, right? This is one of a wonderful way of just trying to ascertain that you optimize the cost and you minimize the revenue leakages. Same is being can be implemented for various utility billings as well. There is another solution around smarter water management, right? Which basically provides for the uses the capabilities of network and asset management, particularly in terms of the metering, the billing, the leakage detection, particularly and the pressure management, either using a hydraulic modeling or something like that, right? Now, what they do is they use various GIS mapping and hydraulic modeling in terms of integrating all this into a SCADA model, right? This is right now already being implemented at Bangalore, with the Bangalore Water and Sewage Board. And if you talk about internationally, then there are a lot of these places, including Melbourne, Netherlands, where this particular solution is already live and working. Now, what they do is they actually work with the typical network, the distribution network of pipes, flow meters, and all. They also work with various GIS data which comes flowing in. Uh, and what the solution does the solution basically displays um, the various events which are triggered because of these sensors which are put up all these places. And these trigger of events create a notification or some sort of a monitoring mechanism which are fed into the dashboard, and which can be monitored or analyzed by the people who are really working on it, like the engineers and all. And what it actually provides, it provides for a real-time view of a particular water supply system in a certain city. It also manages a water management system in a very structured manner, basically covering the various possibilities as well. So, for example, if today's consumption is X amount of million gallons, and at the same point in time last year or 6 months back, how much was that? So, based upon this, the municipality can really go back and do a prediction or a mechanism to have the store, the supply system, the inventory managed based upon this particular prediction, right? It also improves predictability in terms of doing this. It reduces overall the operational cost, and a lot of these overtime which is being done can also be reduced by this. This is another solution which deals around emergency and disaster management. This is already right now work in progress in Chennai, and there's some international implementations are one in Rio in Brazil. There's one in Manila and another in Puerto Rico, right? Now, what they do is they are basically have a standard operating procedures for various real-time situational data, right? Which may be coming from various weather stations that we established. Not sure if you know. There is a company called Weather, which is very old company in terms of doing a predictions and having data sets on weather. IBM acquired this company some time back, and it's part of the IBM portfolio now. So what we have as a part of this is a lot of uh, huge amount of data which is available to us for doing the analysis and getting patterns out of this data, right? So we can have a location specific data in terms of what wind speed, or what's the temperature at a given point in time, all of that, right? Even you can go and you can access. So this service is also available on IBM Cloud, which can be used to get the real time data or even the historical data. It's available on IBM Cloud. It also does a lot of weather modeling in terms of predicting, or when can be a next hurricane or next storm, which can lead to breakup in the electrical network systems, or which can adversely impact the overall water distribution system. For example, in extreme cold conditions, you can foresee next 2 months there is the way that you see the temperature is really going to drop too much, and the water will freeze in the pipes, right? So you can do all that modeling based upon these assets, which are made available. And so we basically create something called as a heat maps, which provides for correlations of various disparate events. What it also does, it also automates the workflows, right? uh, this really helps in understanding the trends of data and understanding and delivering on the KPIs, right? The key performance indicators for a particular system, be it emergency or a disaster management system, right? uh, Okay, so this is one. There is another which is around public safety, which basically talks about how you can integrate the various emergency services onto this platform, right? So I was recently, almost like a year and a half back, working with one of these startups in Bangalore, which was trying to integrate. Uh, so normally, what happens is in a country like India, when you dial a 100, uh, you will not get the response always. So many a time the call just keeps on ringing and nobody picks up the call at the police control room, right? And then you may be in a dire need of help, right? Now, how do you really make them responsible or liable for your calls? So what this startup did was he basically created a hardware and a backend for that. What they did is um, they added a device in the review mirror of the car, right? It's basically a security mechanism. And what they did was this with this device was they make this device a 2G, 3G, 4G, and LoRa compliant. And this device had a in terms of hardware, it had a camera and a microphone capability. And this device was connected to various panic buttons inside the car, right? So whenever there is a problem inside the car, somebody is trying to forcibly stop, or somebody is trying to burgle at a gunpoint, or whatsoever, the passengers can reach out to one of these panic buttons on the side, panels of the car, or the seat of the car, at the top of the car, the roof inside. You just have to reach out to one of these panic buttons, and the moment you click on the button, the audio video of info of whatever is happening inside the car starts streaming at the back end. Okay. Now, when it starts streaming at the back end, this basically logs itself on two different servers. One is it goes to a backend server and stores all of the data, like video and audio coming on a blockchain based ledger. So second is it basically goes to the police control room and it identifies the nearest PCR van, because this information about the device also has a latitude longitude information, and it logs a ticket on the police control room data server, which comes with a timestamp. Number one. Number two, it comes with the device identification with the latitude and longitude. It routes the nearest PCR van to the particular device location, so that whosoever is in the vicinity can go and quickly try to help. But the good part is it also records the streaming of audio or video for next 30 seconds, 1 minute, 2 minutes, depending on what is the need, so that this can be held in the court of law as an evidence, since whatever information is stored on a blockchain based ledger, it's stamp approved. So a lot of these initiatives, like, so similarly, there is an intelligent video analytics service which basically identifies people who are moving on the street, right? And if there is a person who has a shady credential, it can always be mapped. This person can be identified before he can commit some crime, right? So again, a lot of machine learning aspects going into it, a lot of IoT aspects going into this particular thing. So crowd detection, tripwire crossing, facial recognition, right? Somebody doing a illegal parking or a vehicle classification. These are all part of this public safety module there, right? For in India, there's an implementation in Puri. There is another one which is going on in Mumbai. As far as international is concerned, one is in South Africa, Johannesburg, another is in Davao, right beside Chicago and all. Uh, so there is a marquee project which is called the Eagle Eye project, which is implemented in the city of Davao, which is like a single public safety platform which spins almost like all the emergency services, crime agencies, fire and hospital, traffic, and other associated services. So you integrate all these services together so that they leverage on the information which is flowing into this, and they can make the city more safe, more secure. This is really big, right? The smarter waste management system. There is a lot of traction happening around this particular segment, where we see a lot of startups coming up with innovative solutions, a lot of corporates really working on this waste management system. And there is a lot of potential in this. There is a huge financial opportunity, business opportunity in this segment, right? Um, yeah. So again, you would already know this. All these BRTs, MRTs, different modes of communication, transportation are basically integrated so that people get a very unified customer experience. The user gets a very unified customer experience. Be it land transport, be it road transport, be it a rail transport. You integrate all this together. It really helps in one is congestion and removing the congestion, and two is the automated collection of taxes, which is really a quick time saver for the commuters. This is really big. The smarter buildings where there is a layer, there is a floor-wise energy plan, and then you have a floor-wise maintenance schedule. You have a condition monitoring system for different appliances on the floor, and they are actually controlled individually, right? So, an intelligent building management system basically provides for optimization of energy which is needed. So, okay, what can be the forecast? What can be the load shedding? What can be the peak demand? What can be the root cause analysis of particular failure? So, this is all a part of this particular solution, right? This is again built on open standards and has data aggregation, various type of sensors, coming in, integrating together to provide for condition monitoring, right? It is really helpful in the greenhouse gas emission tracking and carbon management as well. So there is a solution which is out there available in carbon management, primarily, using this particular bit. Um, this is I basically talked about at the start of my conversation that there is a smarter grid system which is right now out there in live as a production. In so in Australia and New Zealand, they're already live, and we have been working with Televent DMS and G Power Systems for doing a integration on towards smarter energy segment, right? Which basically includes asset management, smarter metering, um, and of course prediction part piece as well on top of this. Now, we have been talking about this for a while, right? But then let me quickly give you this. So far, we have been mostly working on what we've seen implementation in the space of IoT and AI. We go a level ahead of this and we talk about, something adding to the cognizance of it, the cognitive system. So human beings are typically very good at these pieces: common sense, imagination, abstraction, dreaming, generalization, and all. We're talking about cognitive systems which basically use this in terms of what to get a to create pattern identification mechanism, to do a natural language, for doing a bias elimination, and this all has actually endless capabilities, right? This is a typical pipeline where the systems observe, they interpret, they evaluate, and then they decide as well, right? So it's a reinforcement based learning model where you have all the descriptive, diagnostic, predictive, prescriptive, and all feeding back to the cognitive cycle, right? This is how humans do. We learn from our mistakes. We learn with what we do. We learn on a daily basis. We learn as somebody is talking to us, right? And based upon that, we ingest the data and we, add it to our learning. So this is how the systems also work here. Um, this is what we're talking about. So in last so many years, we have taught people to understand computer. Now we are actually teaching the computer to understand people. This is what is cognitive in a nutshell. And IoT is actually, and AI is actually the heart of all of these cognitive systems, right? So we talked about machine devices, sensors. We talked about all these network interaction where these devices flow the data back into the systems, connecting through a gateway. We also talked about IBM Watson IoT platform, which is hosted on cloud, where all these data come and get aggregated. And we talked about data analytics piece, right? Yeah, so this is just an infographic around type of devices which are connected today. And this is just an infographic about what sort of scaling do we see going forward, right? Right from some 10 billion, say 5 years back, to 30 billion, which is 3 times within a span of 5-6 years, right? And we see this tripling in next maybe 20-30 years. Okay, so we'll quickly skip this piece. Yeah. So ISS has turned to IBM Watson to transform the management of its 25,000 buildings globally. What we are doing with them is we are actually integrating their millions of sensors, devices which are embedded into the buildings, and we are uploading all this data into the IBM Watson IoT platform, and we are analyzing it there, and we are using the cognitive computing technologies to learn from this data how ISS can optimize the services, and how are people using these services in the buildings, what can be the power consumption, what can be the rate of failure, and all that stuff, right? Not sure if all of you understand what Watson is about, but then Watson has few names to it. It's all about so it was a supercomputer as well, which won a Jeopardy competition in 2011. There was a recent project Debater, if you'd have heard of, which is again built on top of Watson, which in which uh, you know uh, uh, there is a machine which is debating with a human being just like humans debate, right? So it will listen to you, it will understand the perspective, it will talk to you, it will talk about pros and cons of things, right? So Watson is basically a cutting edge which allows users to pose questions in natural language and receive responses with confidence measuring. For example, the machine is 80% sure about what it is talking, so it's telling based upon whatever evidence I have, I'm 80% sure about the answer that I'm giving to you. And this is like a continuous learning mechanism for it. So we have been using Watson in so many domains, including cancer research, including Watson IoT platform that you just saw. Okay, so it basically is into deep content mining and rapid deployment of various information applications. And the good piece is the scalability. Um, okay, what I'll do is I'll quickly, give you this. In case you have any learning, you want to understand how is Watson IoT platform working, you'll go to YouTube. You can search for these videos there. You can also go to IBM Cloud and you can actually create a service there, which is offered free of cost. You can work on that service to leverage various offerings there. In case there is any other question, you can always come back to me. These are my coordinates. Before I end up, I'd like to again, take a few questions in case if there are any in the room.
You can ask.
Any questions? Anything?
Hello.
Yeah.
Sir, I have a question. I was watching a video on YouTube and there was an interview of an artificial intelligent robot. And a question was asked by someone that, what do you think of human fate in the future? So she replied that I think that human have increased a lot in number, which was out of artificial intelligence. So what do you think about that?
Okay. So I'll have to, maybe ponder upon what you said, but then uh, I'll give you a small example before you arrive at the answer of this question. We are recently working with AIMS and Triple IT Delhi in terms of creating a solution for understanding a particular cancer patient, whether when he goes to, so what happens is when a cancer patient goes for chemo, before that chemo process, he has to actually, so there is a test done based upon which you identify that how much of the cells in the test in that particular test are malignant versus how much are healthy. Based upon the inference of this test, you decide or the doctor decide whether this patient should go for chemo or not. Now we did a solution. We created a AI based ML based solution for them, and the solution came back and reported the accuracy of 83 to 87%. Right. So with the AI ML based system, and AI ML based systems are not going to replace human beings. They're basically only going to add to the overall expertise that humans can deliver, because humans have capabilities, right? Limited capabilities. I'm trying to come to is, AIM said that they would only be implementing this solution as a production ready solution when the solution is able to give an accuracy of 95 to 97% of accuracy, right? Compared to what it has, 83 to 85% of accuracy, right? So AI ML based systems need to learn ingest on a regular basis, right? So a particular outcome or a particular result response, as you said, may not be accurate, but then AI systems are only as good as they have been trained for. So it will take some time before will be able to roll out this cancer system that I was talking about in a production ready environment. So the point I'm trying to make is AI systems really need some time to really be capable enough to be 100%, right? So till the time, it's more like they're just trying to help by complementing human capabilities. So AI is not going to replace human being. Okay.
Thank you, sir.
Yeah. Any other questions there?
I believe, Dr. Madhukar, that is, all our participants are satisfied with your session that you have conducted for us. And any questions, any more questions? So, sir, I think we'll wrap up the session with that. Thank you so much for being with us.
Thank you. Thank you. It was a pleasure interaction. Thank you.
Okay, sir. We have a field visit planned to Chandigarh Smart City office in Sector 17. So we will assemble at the reception at 3 o'clock. Meanwhile, you can have a break for half an hour, and we meet at the reception.
Which reception?
Reception of Homi Bhabha block. We have a mini bus. It will be parked outside. You can have a seat in that.
Charul, if participant, अच्छा sorry चले गए, ठीक है. Okay, okay.
Yes.
I think if they have any query, they can ask. It's offline.
मैम डिस्कनेक्ट कर दूं ये?
हाँ चारुल, आप अपना सिस्टम निकाल लीजिए, कर दीजिए डिस्कनेक्ट.